This is Math 3 Final Review Unit 2. We are going to start off with some solving problems. Number 1, absolute value of 5x plus 3, close absolute value, plus 1 equals 14. All right. It's been a while. Does anybody remember the steps? Yes. Good. We subtract the 1. So step 1 was to isolate the absolute value. What does isolate mean again? To get the absolute value by itself. So we subtract 1. Does everybody agree with Maddie? Yes. Who said yes over here? I thought Maddie answered for herself. Like, yes, I agree with myself. Okay, so yes, you agree with her, minus 1. Absolute value 5x plus 3 equals 13. And now that it's isolated, who remembers what we do next? Yes. You're close. We square root both sides if there was a quantity squared. If there was a quantity squared, we'd square root both sides and put plus or minus. We get rid of the absolute values by making two cases. One of them equals a positive and the other equals a negative. So kind of like square rooting both sides. Kind of like it. Okay, so we make 2 cases. 5x plus 3 equals 13. 5x plus 3 equals 13. 5x plus 3 equals negative 13. Oh, and you solve each one. So go ahead and do that now with your shoulder partner. Subtract 13, divide by 5. Subtract 13, divide by 5. You will get 2 different answers because one of them is positive 13, and over here you're subtracting from negative 13. Come on, I will need you guys working and talking with your shoulder partner. I'm going to take this off screen for just a few seconds so I can do it myself. Come on, guys. Stop the goofing around. Check with your shoulder partner. One of them should be a whole number, the other one should be a negative fraction. One of them should be a whole number, the other one should be a negative fraction. All right, is that what you guys got?
No, I got it.
All right. Ciara? Never mind. Okay. We're good? Okay. Questions on number 1 before we move on? Okay. Number 2. Negative 2. Absolute value x plus 3, close absolute value equals 6. Is it okay to distribute the negative into the absolute value? No. No. Is it okay to ever distribute anything into an absolute value? No. Never. What do I do to get rid of the negative 2? Yes. Divide. Divide. I don't add it, I divide it out to the other side. So, divide by negative 2. Absolute value of x plus 3 equals negative 3. Now, back when we did this for the very first time, we solved it, we made 2 cases, and then we plugged it back in and it didn't work. Does anybody remember why? I'm hoping not to have to do all that in this one. Does anybody? And you said it without raising your hand, but that is correct. Amaya, you were about to raise your hand. Were you going to say the same thing? Same thing?
Shut up.
Okay, okay. Okay, with raising our hand next time. He said because the absolute value can never equal a negative number. Do you guys all agree with that? So what would we say here? No what? No solution. And if they ask you to explain, you would say what Michael just said. No solution because an absolute value can never equal a negative. All right. Questions on number 2? All right. Number 3. Absolute value. 2x plus 7, close absolute value, less than or equal to 11. All right. We are jumping right into all the different possibilities. We addressed one with an equal, solved it, got 2 possible solutions. We addressed one with an equal, but ended up with a negative, and we addressed it, it's no solution, and Michael pointed out why, because an absolute value can never equal a negative. And now we jumped right into how do you solve with when there's an inequality. Now, we still make 2 cases, but we put special words in between. There was 2 special words we picked from. Does anybody remember what of the 2 special words they were?
And or?
It was or, and or. Do you guys remember that? Does anybody remember the trick we used to decide which one was which?
Sandwich.
There was a sandwich, there was a sandwich.
And then the oars went outwards.
The oars were like the boat oars that went outwards, and the sandwich was like a sandwich inside. Good. And then we looked here to decide. There was a less than and a greater or. Do you guys remember that? Less than and a greater or. Let's look in our notes really quick. Let's flip over. What unit is this? Unit 2?
Yeah.
Let's flip over to Unit 2 and see if we have it in here. Here it is. Here it is. It's lesson 2-3. So flip over your notes to lesson 2-3, or you can just look at mine because I see some of you not flipping. Lesson 2-3. It's right here. Absolute value is greater than a number. It's or. Absolute value is less than a number. It's and. And we said greater or is or, less than and is and. Yes? Do you guys remember that? Okay. So your choice to write this down again or make a note to yourself right now. This is from lesson, what lesson was it? 2.3. You can look back. Okay, so I'm going to rewrite it. 2x plus 7 is less than or equal to 11. The first one always stays at exactly as it was printed on the paper. And then the next one, we flip the inequality and make it a negative. So I'm going to rewrite it. 2x plus 7 is less than or equal to 11. The next one is 2x plus 7 is greater than or equal to negative 11. And what's the word here? And or if this is less than and. And. So once I solve it, and I am going to have to sketch it, it should be a sandwich in the middle. All right, let's solve. Subtract the 7, and then we're going to divide the 2. 2x is less than or equal to, what's 11 take away 7? 4. Divide by 2 is 2. And then this one here, we're also going to subtract the 7, but this time we get what? Oh, I crossed out the wrong thing, but it's okay. 2x is greater than or equal to what? Negative 18. Okay, and that is negative 18. And then we divide the 2x, the 2 from the x. And what do we get? Greater than or equal to -9. Now, with these, remember, whenever you get an answer that's an inequality, that's when you sketch it and then write it as a bracket, parenthesis type answer. I'll show you what I mean. Okay, so we do this. The smaller number always comes first. What's smaller, -9 or +2? Open or closed circle? Closed because of the equal bar. +2 is bigger. Open or closed? Closed. It doesn't matter which one you graph first. I'm just going to graph the -9 first because I'm going from left to right, but it doesn't matter. This reads x is greater than or equal to -9. You either know how to shade that it's to the right, or you use the trick where you can only use the trick if x comes first, which it does, and it's the arrow trick. You're going to shade to the right. This reads x is less than or equal to 2, which is everything to the left, or you use the arrow trick as long as x is on the left-hand side, everything to the left. And I only shade where there's overlap. Where's the overlap? In the middle. And is it a sandwich between two numbers the way it should be? Yes? Yes. Occasionally it's not. It shades everywhere, or it shades on the outside, in which case it's no solution. But most of the time it's right in the middle, like it should be. -9, 2, parentheses or brackets if they're closed circles. Brackets. Goes from -9 to 2 with brackets. Any questions on number 3? Yes. Okay. Number 4. -4, absolute value, x minus 3, closed absolute value is less than -8. Okay, now before you go on and say, oh, no solution, blah, 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 because of the negative, you have to isolate first. And what am I going to divide by when I isolate? And when I divide by the -4, what's going to happen to the negative on the right-hand side? Is it going to become positive? So am I going to end up with a solution here?
Yep.
Yes, so don't jump to, oh, no solution, or blah, 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 and especially if there's an inequality. Okay, so divide both sides by -4. And because there's an inequality, what happens when you divide by a negative? It switches the inequality, so it's greater than +2.
Is it when you divide or multiply by
Good job. She asked a question. If you didn't hear her in the back, she said, is it when you divide or multiply by a negative? Yes. Either of those two cases, multiply or divide by a negative number, is when you flip the inequality. If you didn't remember that, you can write it down in your notes. If you're like, yeah, I got it, I remember, you don't have to. But if you forgot, it's when you multiply or divide by a negative number, you flip the inequality. Okay, we're going to make two cases. X minus 3 is greater than 2. X minus 3 is less than -2. And when I graded your guys' test way back in Unit 2, I had quite a few kids that forgot to put the word here and got docked points. You're going to get docked points. And on the final, you're going to have to, it's going to have both options, and or, so you need to know which one to pick. Looking here, what symbol is that? Greater than or less than? Greater or is what? And do you guys remember the shorthand or the way I told you guys on whether to know it's greater than or less than if you're still struggling? If it looks like a what? If it looks like an L, then it's less than. If it doesn't look like an L, then it's greater than, right? Less than, and, greater than, greater or. Yes? Okay. All right. Go ahead and solve add your 3. Okay, what do we get here? 1. Thank you. Okay. So we have x is greater than 5 or x is less than 1. Yes? Graph it on a number line. Smaller number to the left. Which one's smaller, positive 5 or positive 1? 7. Which one's smaller? 1. And then bigger is 5. Do you agree they're both open? Yes or no? It doesn't matter which one you graph first. You can graph this one because you go from left to right, or this one because you're going from left to right on the work up here. So let's do this one first. X is greater than 5. Do you guys see that it's greater than? It's eating the x. So x is bigger than 5. Anything bigger than 5 is going to the right or to the left? To the right. X is less than 1. It's an L. Anything smaller than 1 is everything to the right or left? Left. Is that a sandwich, or those the boat oars or the bunny ears? Which one is that? The boat oars. And is that okay for an or problem? Yes. In the interval notation, will that look like this one up here or with the union in the middle? Union. So how would I write this one? Does anybody remember? Negative. How do I start writing it? Negative infinity to, what do I put on the negative infinity? Parentheses or brackets? Parentheses. Always parentheses. And because the one has an open circle, what do I put? Parentheses union, parentheses 5 to, it's been a long time since we've done those. Do you agree? Okay, good refresher at least. Okay, number 5, absolute value of x plus 4, close absolute value, plus 3 is greater than or equal to 0. A good amount.
Oh no. I really think we should do all of them.
What?
We should cut out about 74%.
No. Okay, we're ready? I'm going to call this A. I'm going to call a 5A and a 5B, and there's a reason why.
Well, you don't want to.
Okay, what am I going to subtract? Okay, and I have absolute value of x plus 4 is greater than or equal to negative 3. Okay, now this one I do have to think about. Should I have a negative 3 on the other side? Yes or no? Like the one I had up above that Michael answered being a negative and he said no solution, we have to think about. Before we put an answer there, let's talk about letter B. Letter B, I'm going to write the same thing. X plus 4, absolute value, plus 3 is less than or equal to 0. Let's also subtract the 3. And that gives me x plus 4 is less than or equal to negative 3. Now they look pretty much the same. They are pretty much the same, but are they exactly the same? Yes or no? Because the inequality is flipped around, does it make a difference?
Yes.
Okay. Does anybody remember the difference between the answers? One of them is a certain answer and the other one's a different answer. Yes? No? Yes? Not which one's which, just what type of different answers are they?
Infinitely and no solution.
Okay, same thing. One of them's an infinite, negative infinity to infinity, and the other one's no solution. Do you guys at least, now that she said it, oh yeah, I remember that. Okay, now that she pointed it out, does anybody remember which one's which? Maybe? Okay, I'm gonna give you time to talk to your shoulder partner. Here's what you're thinking about. Look at the symbols. This symbol here on part A is opening this way. That's not less than, that's greater than. Sorry, right here. When is absolute values always positive? When is a positive number bigger than a negative? Talk to your shoulder partner. This one here, absolute value is always positive on part B. When is a positive number less than a negative number? Always or never. Talk to your shoulder partner.
This one's
All right. Okay. So before we talk about infinitely many and no solution, which one's always, which one's never? This one is a positive number. This one's a positive number. A positive number is greater than or equal to a negative number, less than or equal to a negative number. This one is always or never? Always. Do you guys agree? Yes or no?
I agree, but like I'm just confused because how can a positive ever be equal to a negative? Because it says greater than or equal to. Like how can it ever be equal to?
It doesn't matter that the equal bar is there. The equal bar doesn't have to be there. Is it always going to be at least greater than?
Yeah.
Yes.
I'm not asking them.
No, she's not. She's not. Even if the equal bar wasn't there, the fact that it's always greater than.
I understand, but like,
Yeah. Okay, so pick a 5. Is 5 greater than or equal to? Doesn't have to be equal to, but is it greater than or equal to -3? Yes. Any positive number is going to be at least greater than a negative.
but it can never be equal.
No, it doesn't have to be equal to. It just has to be greater than.
I'm not even thinking about it.
She's not. I'm not saying it has to be equal to. I'm not saying it has to be equal to.
Okay, I'm just trying to understand.
Okay, so the equal bar is not necessary, because even if it was, Michael, Maya, even if that equal bar was not there, this would still be true. The equal bar is not necessary. All right, guys, what about this one? When is a positive number less than a negative number? Never. So the equal bar is not necessary, is what Maya pointed out. It happened to be there, but is it necessary? No. Okay, so here what would we say? Negative infinity to infinity. And this one over here, we would say what? No solution. Some of you, I've heard you say no soul, no solution. Okay, we're good? All right, moving on. Number 6. Graph. Shh, guys, stop the talking. Okay.
Can you move it down?
Yes, sorry. Graph. Y is greater than or equal to -1, and y is less than or equal to x plus 1. We're graphing those two together. On the same coordinate plane. Okay. First one, what kind of line is that? It's linear. I'm going to put that one in green. It's linear and what? Y equals a number. Why are you sleeping? What kind of graph is that? Is it vertical or horizontal?
It's the
It's the horizontal one?
41%.
Yes?
yes.
Okay. And I'm going to go down here to -1. Is it solid or dashed?
Yeah.
Right here. Solid or dashed? Solid. And which way would I shade if it's greater than or equal to? It's above or below. Which way would I shade? Would I shade above it or below it if it's greater than or equal to? I'm going to lightly shade in pencil. I would shade above, correct? Yes or no? Above. Okay. Guys.
What?
Okay. Next one. I'm going to put here, I'm going to go up 1. Guys, I'm going to go up 1 and then the slope, up 1, and the slope is 1. Up 1 over 1, up 1 over 1. Is it solid or dashed? Solid. And I'm going to connect. This is above. This is below. This says y is less than or equal to because it looks like an L. Would that be above or would it be below? Below. I'm going to lightly shade that in pencil and I darken in where there is crosshatch. Where do the two lines intersect? Down here or right here in this like little triangle piece? In the mouth in the triangle piece. I'm going to color that in darker. Like this sideways Christmas tree area. Do you guys see it? Yes. Okay, questions on number 6. Okay, number 7. Solve. Yes. The quantity of x minus 3 squared minus 2 equals 8. Okay, when there was a quantity squared, we solved it a little bit differently. When there was a quantity squared, we kind of treated it like an absolute value. We isolated the quantity squared. So what would I do with this minus 2? Add it. Good job. So I would add the 2. And what would that give me? The quantity of x plus 3 squared equals the quantity of x minus 3, squared equals what? 10. And then what would I do to both sides? Square root. And why? Because the square root is the inverse operation of a squared. Inverse operations mean they undo each other, and what I do to one side, I must do to the other. Now, you may not remember, but way back when we first did it, we did absolute values because square roots could only be positive. Do you guys remember that? And then over time, we just did plus or minus. Okay, so square roots and squares undo each other. Plus or minus. Is 10 a perfect square? The square root of 10, does that come out as a perfect square? No, so it's just going to be root 10. Do any pairs come out? Can you guys think of that in your head? What does 10 break down to? Do any pairs come out? No. Okay, I'm going to leave it. What's the last thing I do to get x by itself? Add the 3. Now when I add the 3, or the 3 and the root 10, not 3 and 10, but the 3 and the square root of 10, are those like terms? So this is how I write my answer if you remember it. 3 plus or minus root 10. Because I cannot combine them because they're not like terms, that's how I leave my answer. 3 plus or minus root 10. Now, let's say root 10 was root 12 and I was able to break it down. I would have to, and I'd get something like 2 plus or minus 2 root 3. And that's okay as an answer as well. Questions on 7 before I move on to 8. Okay. 2x squared minus 6x plus 5 equals 4. Is this a quantity squared like the last one? Okay, so I'm not going to treat it like the last one. What am I going to do? Because it's an x squared and an x, I'm going to make the equation equal to what?
0.
Does anybody remember? Well, let's do that first. Let's get it equal to 0. I'm going to subtract 4 from what like term? First term, second term, or third term? Because that's its like term. Guys, please stop. 2x squared minus 6x plus what? 1? Does anybody remember why we do this? Good. So we can double bubble so that we can factor and solve. Why do we need it to equal 0 so that we can factor and solve? So that we could use the zero product property. Check with your shoulder partner if that factors. Try to factor and solve. Well, with the people in front and behind you.
I'm sorry.
Okay, does it factor? I don't think it factors, does it? It should, and here's why, guys. Look, when you try, the only factors for 2x squared are what? 2 and x? The only factors of 1 are 1. And is this ever going to give you 6? No. It doesn't factor. No matter how hard you try, it's not. Okay, now factoring is our best option. At least I would much rather factor any given day. But if it doesn't factor, does anybody remember what we resort to?
The quadratic.
Good job. Quadratic formula. X equals, who said that? That was a classroom grown complaint altogether. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now do not forget to find your a, your b, your c. A, B, C are always in order if your polynomial's in order. Ax squared plus bx plus c. What is a in this problem? It's your leading coefficient. And you never take x's or variables, or x's, just your coefficients, your numbers. What's a? And it's okay if they're negative. What's b? And what is c? All right, and then you're going to plug it all in. X equals opposite of b plus or minus the square root of b squared minus 4 blank blank all over 2 blank. Plug everything in. And then work it out with your shoulder partner.
because I'm not comfortable. And I can't get comfortable in the chair. It's too hard.
You should go get one of those kids.
The colorful ABC ones. The mats, the puzzle ones. Okay, what do I plug in for the B? 6 or negative 6?
Negative 6.
And here negative 6, and then A is 2, C is 1, and A is 2. Yes?
Yes.
Okay. Opposite of negative 6 is 6 plus or minus the square root of 36 minus 4 times 2 times 1 is 8. Yes or no? Now, as tempting as it is to reduce those, do I ever reduce those right away?
No.
Never, ever. Ever. Okay, so then I have x equals 6 plus or minus the square root of, anybody calculate 36 minus 8? 28. I still don't reduce. Now let's say I could not go any further. Let's say 28 was 5, and I couldn't break it down into its prime factors. I would stop and be done. Let's just pretend. I could not go any further. I would stop and be done. I could not reduce those because there's a 1 here, and there's no number that reduces with 6, 1, and 4 all at the same time. But can I break down 28 into its prime factors? Using the factor tree. Do that now. If you're gonna, anybody tell me what you're using for 28, what prime factors?
7.
Okay, so 7 and 4, and then 4 is, so 2, 2, and 7, what does it become?
2 square root 7.
2 root 7. All right, so then you have 6 plus or minus 2 root 7 over 4. Now can you reduce?
No.
Right here. Here's what we're trying to reduce. The 6, the 2, and the 4. Can I reduce all three?
Yes.
Is it was negative 6, but the opposite made it positive. What can I reduce all 3 of those numbers by?
2.
6 becomes
3.
2 becomes 1, and 4 becomes 2. All right. And we are ready. Our final answer is 3 plus or minus. You do not have to put 1 root 7. You can, or just root 7. It's up to you. All over 2, and that's your final answer. Any questions?